Hi future doctors, welcome to the next class. In this class we will discuss about law of conservation of angular momentum. So we came to know law of conservation of linear momentum. In that case what we got, if external force is going to become zero according to Newton's second law, momentum is going to be constant. Momentum constant means mv is going to be constant whenever external force is going to become zero. Now you may get idea now. Here what should be zero if external force is zero means in comparison external torque is going to become zero. How is equal to rate of change of angular momentum. So if tau is zero external tau, then L is going to be constant. What is L here? Angular momentum. I omega constant. What is the meaning of this? I is inversely proportional to omega, or omega is inversely proportional to I. If moment of inertia increases, angular velocity decreases. If moment of inertia decreases, angular velocity increases. On what factors moment of inertia depends? Moment of inertia formula is equal to mr square. Distribution of mass, distance of those mass particles, and position of axis of rotation. So if this is the object, axis of rotation may be within the object or outside the object. This is nothing but how moment of inertia is going to be depending. So if you are a person is going to be rotating on a turning table or rotating table. So if this person is carrying two dumbbells in his hand, so whenever dumbbells are going to be stretching like this, whenever he is bringing these dumbbells like this, holding his dumbbells like this, whenever he is bringing towards his body, so then this distance is going to decrease. Whenever distance decreases, moment of inertia decrease because distribution of mass particles near to axis of rotation. So whenever a person is dancing, whenever he is closing his hands towards his body, then he is reducing R. Then moment of inertia is going to decrease. Whenever moment of inertia decreases, angular velocity is going to be increasing. At that time, the dancing person can make so many rotations because he increased or she increased angular velocity by decreasing moment of inertia. How he is decreasing means by bringing his hands here, by bringing dumbbells near to his body or axis of rotation. So a person is jumping from the swimming pool. He is going to close his hands and legs very near to his body near because he wanted to make more angular rotations. So whenever he is reaching water, he is going to stretch his hands like this, hands and legs, because to decrease the moment of inertia, he is bringing his hands and legs away from the axis of rotation. At that time, moment of inertia is going to increase, angular velocity is going to decrease. So this is the concept according to law of conservation of angular momentum, where moment of inertia increases, angular velocity decreases. How they are going to make this one only they are going to ask in problems. How we have to do in problems, we will see. So now in this mainly common angular velocity. So this is the axis of rotation. One disk is rotating, its moment of inertia I1, its angular velocity omega 1 you can take. So another disk, either larger disk or smaller disk. So another disk is going to be placed gently on this. They are going to give, which is having angular velocity. Very slowly they place because external torque should become zero. They won't give external torque is zero. Like this, they will give the question. If you do one or two questions, you will get idea. We will do those questions also. Very important model. So whenever they place it gently on this axis of rotation, now what is the common angular velocity of these two? They are going to ask. So what is the common angular velocity? Omega. And what is the resultant moment of inertia means we are going to apply law of conservation of angular momentum. How we will write means I1 omega 1 plus I2 omega 2 is going to be equal to I1 plus I2 omega. Then omega is going to be angular velocity is going to be. So I1 omega 1 plus I2 omega 2 by I1 plus I2. So this one will be coming in collisions lesson. In collisions lesson, common velocity after collision in perfectly inelastic collision. What is the formula? V is equal to m1u1 plus m2u2 by m1 plus m2. In place of mass, we will get moment of inertia. In place of velocity, you will get angular velocity. If both are rotating in same direction. So one is rotating like this, omega 1, another one is rotating in opposite direction. At the time, common angular velocity I1 omega 1 minus I2 omega 2 by I1 plus I2. So, angular velocity direction is reverse. Total moment of inertia remains same. So, this is about common angular velocity. The second object is at rest they may give. At the time, omega 2 is going to become 0. Next, in this, we might have discussed loss of energy, loss of kinetic energy. What is the formula? Did you remember? Of m1, m2 by m1 plus m2, u1 minus u2 whole square. So that is loss of kinetic energy. So during inelastic collision. So same like this, what is the loss of rotational kinetic energy? First of all, what is the equation for rotational kinetic energy means? In similarities, linear kinetic energy of mv square. Now, rotational kinetic energy. Rotational kinetic energy is nothing but half. In place of m, what we will write? In rotational dynamics, I. In place of velocity, we will write omega. So, of I omega square. Now, you might have got idea. So, this is the rotational kinetic energy. K1 is equal to of I1 omega 1 square. K2 is of I2 omega 2 whole square. Now, resultant kinetic energy, net kinetic energy of after rotating combinedly I1 plus I2 omega square. Omega is nothing but this one. So, if you subtract similar to this equation, directly I am writing. So, loss of rotational kinetic energy delta k is going to be half. In place of m1, I1, I2 by I1 plus I2 into omega 1 minus omega 2 whole square. If both are rotating in same direction, so minus will be coming. So for opposite direction, for this one, what we are going to get loss of rotational kinetic energy means of I1 I2 by I1 plus I2 omega 1 plus omega 2 whole square. So previous year questions also PYQs by assuming NYQs. Next year questions we can assume from those PYQs. So very important concept. So you have to do 10 to 15 minutes or half an hour. We have to practice on this only law of conservation of angular momentum. How they may ask the question. So without acting external torque, how we have to read, understand. If you do means definitely you will be getting all these problems related to this. This is like collisions and this one similar equations. Total three types we will get equations. One is from collisions, these two. Now law of conservation of angular momentum. These two equations you got. Next, what you will be getting in capacitors, already we said common potential, similar equations. Next, on this how they may ask. So planet or earth of radius r, mass m, so which is rotating with angular velocity omega. Then radius of the earth is suddenly is going to become half. Radius of the earth is going to become half or 1 by nth part they will give. First we will discuss for half, then 1 by n what is going to happen we will say. By keeping its mass constant. Then what happens to its time period they will ask. Okay, at the time it is going to become suddenly half, no external torque is acting, therefore you have to apply law of conservation of angular momentum. For that I1 omega 1 equal to I2 omega 2. Now what is I1? Moment of inertia of this earth or planet about diameter. What is the formula? 2 by 5 m1 r1 square as solid sphere if you assume. Omega 1 is 2 pi by t1. T1 is time period of the earth. Next, I2 2 by 5 m2 r2 square. Omega 2 is 2 pi by t2. So if we cancel 2 by 5, 2 by 5, 2 pi, 2 pi, if mass of the earth is constant, then m1 should be equal to m2. Then you can cancel m1 m2 also. Then what will be remaining finally? r1 square by t1 is equal to r2 square by t2. So then t2 is r2 by r1 whole square into t1. Here again directly proportional, inversely proportional. Wherever you go, we will be getting always some relation between those two physical quantities. Our first video in basics, directly proportional, inversely proportional. Now what 2 is r1 by 2. If you substitute here r1 by 2 r1 whole square, what you will get? t1 by 2 square. t2 is, if r1 by 2, if we have given, we got t1 by 2 square. If r by n is given, what you will get here? t2 is t1 by n square you will get. Correct? Now what is the new time period means? Old time period is time taken to complete one rotation, 24 hours. So 24 hours by 4. So it is going to become 6 hours. If radius is going to become half, you have to assume now suddenly radius is going to be doubled. Suddenly radius is going to be 1 by 4. What will be having? What will be having? You have to create that question. That is only next year question I am saying. NYQs. Okay. So here we discuss R by 2. What they will give, we don't know. What they are going to give in final exam, we can't expect. But that one, they may give like this. If you solve means, it will become easy for you people to solve in your final exam. So, final formula, T dash is equal to 24 hours by n square. If mass of the planet is going to be constant. Sometimes they will give by keeping density of the planet is constant. So if density is constant, how this formula is going to be changed? So again same, I1 omega 1 is equal to I2 omega 2. So in place of M1, you have to write density. How you will write means, density rho is equal to mass by volume. In place of mass, density into volume. So what is the volume? 4/3 pi r cube. Here we have to write that one. So I am writing directly from this equation. In place of m1, what I have to write? 4/3, this 2 by 5, 2 by 5 I am cancelling, only m1 r1 square by t1, m2 r2 square by t2. In place of m1, rho 4/3 pi, rho 1 4/3 pi r1 cube. In place of m1 I am writing. In place of m1, rho 1 4/3 pi r1 cube. This r1 square only, divided by t1. Next, right side what you will get? Rho 2 4/3 pi r2 cube. Now what you will get here? R2 square by t2. R2 square by t2. Just to write direct formula, I am writing those. Now if you cancel 4/3 pi, 4/3 pi, if density is constant, now rho 1 should be equal to rho 2. Those two also cancel. Now what you got here? R1 power 5 by T1 is equal to R2 power 5 by T2. Therefore, what you will get? T2 is T1 by n power 5 you will get. Here what you got? N square you got. Here n power 5 you will get. Now for this problem, R1 by 2, if you substitute, what you will get? T2 is going to be equal to T1 by 2 power 5. Isn't it? 24 hours by. So 2 power 5 means how much? 32. 2 square, 2 square, 2. 16 into 2, 32. Correct? 24 hour by 32. So these two formulas you should remember. This is when density is constant. So when density is constant, T by n power 5. When mass is constant, T by n square. The T value is going to be, so time taken to complete one rotation of the planet. They may give some value, not 24 hours, 30 hours, 20 hours, that is their wish. Therefore, we have to assume the question, then we can get answer very clearly. This is law of conservation of angular momentum. So, this angular momentum, whenever we are applying, it should be very careful. Still some more problems will be there. Definitely, we will discuss those also in upcoming problems. But concept, how to apply, we discussed here. I hope you people understood. Thank you.